Okay, we're back, and we're on the back of the notes here. Well, you were probably thinking, Mr. Cavell, I know you're going to make this harder, so let me make this harder. The thing you have to remember about this, though, is that the process does not change. The rules stay the same. It doesn't matter how complicated it looks, you're doing the same thing over and over. In number 14, we're just going to think of this as two pieces. You have x squared raised to the fourth power times x to the third raised to the third power. Well, let's take the first set of parentheses. Let's deal with that. So x to the second raised to the fourth. When you multiply a power, when you raise a power to a power, you multiply the exponents. So we keep the base as x. 2 times 4, x to the eighth. Times x to the third raised to the third power. Keep the base, multiply the exponents. 3 times 3 is 9. Now look at what you have. X to the eighth times x to the ninth. That's the same variable. We can multiply those together. Now when you multiply variables, what do you do to the exponents? Do you remember? You add them up. So we get x to the 8 plus 9, which equals x to the 17th. That is your answer. Okay? If you get confused, why do I add the exponents? Think about expanding this, write it down, x to the eighth, you'd have to write x 8 times. And then you'd have to write this x 9 times. So how many x's are multiplying? 17. So the shortcut, add those up. All right, let's do 15. X to the fourth raised to the seventh. All right, let's multiply those exponents, x to the 28th. X to the second raised to the 10th. Power to a power, multiply the powers, x to the 20th. And then this is just, that's x to the 1 raised to the third, so that's x to the third. 1 times 3 is 3. Okay, you got rid of parentheses. Now, can we combine these? Yes, we can multiply the variables. You keep the variable, you add the exponents. So we get 28 plus 20 is 48 plus 3. This is actually really good mental math practice as well. You know, try to do as much of this as you can, you know, in your head. All right, you can use the calculator too, but we're also working on our mental math. Now, 16, this you got to be careful. You have a negative outside parentheses. We will not deal with that until we have done the parentheses part, which was negative 2x raised to the third. Now, there are no exponents inside these parentheses, but we can say negative 2 to the 1 and x to the 1. And then we're going to distribute the outside exponent, which is the 3. So, you have a negative. Don't forget that. Then I'm going to put a big set of parentheses here. This is negative 2 raised to the third power. 1 times 3 is 3. And then x to the third power. Now, negative 2 to the third is negative 2 times negative 2 times negative 2, which is going to be negative 8. And then x to the third power. Now we can take care of this negative. This is like a negative 1 times a negative 8. Negative times negative equals positive. That's 8x to the third. And that's how you do that. Let's take a look at 17. X to the 1, y to the 1, z to the fourth, all of that raised to the second. Power to a power. We're going to keep the bases. We're going to multiply the exponents. 2 times 1 is 2. 2 times 1, that's y to the second. 2 times 4, that's z to the eighth. Times. Now we do the same thing with this set of parentheses. 5 times 3 is x to the 15th. 5 times 1 is y to the 5th. 5 times 2 is z to the 10th. It's like doing two problems. Okay, we do the first set of parentheses, that's the first problem. We do the second set of parentheses, that's the second problem. And then the last thing we do, now we can multiply these together. When you multiply the bases, keep the base, add the exponents. Multiply the y's, keep the y, add the exponents. multiply the z's, keep the z, add the exponents. We get x to the 17th, y to the 7th, z to the 18th. All right, let's try 18 here. Complicated problem. We're going to take our time because we want to make sure we get this right the first time. If you get this wrong and then you have to redo it, that's what makes math a long process. So let's try to get it right. 5 to the first raised to the second. That's 5 to the second power. That's not 10, not 5 times 2. That's going to be 5 times 5. And then that's x to the 2 times 2 is 4. Y to the 2 times 3 is 6. And then we move over here. Times. This is negative 2 to the first. We're going to distribute this 3 outside. Exponent. So that's negative 2 to the third. X to the 3 times 4 is 12. Y to the 3 times 7 is 21. All right, let's simplify a little bit here. 5 squared is 25. 5 times 5. Negative 2 to the third is negative times negative times negative. That's going to be negative 8. X to the 12th, y to the 21st. Okay, last thing we'll do, let's multiply the coefficients. 25 times negative 8. I would use the calculator probably on that one. You get negative 200. X to the 4 plus 12. Add the exponents. Y to the 6 plus 21. And we get negative 200. X to the 16th. Y to the 27th. And that is the answer. Whoops. Negative 200. X to the 16th. Y to the 27th. That's a 7. All right, let's look at 19. Okay, we'll do a few more of these here. Look at 19. That's x to the second, to the third, and then this is to the fourth. That's hard to see. That's a 4 outside. Let's work from the inside out. X squared to the third power. Power to a power, you multiply them. That's x to the 6th. And then that's still raised to the 4th. Power to a power, you multiply them. X to the 24th. That's it. Let's skip down here to number 22. 22 and 23. Now, these are interesting. They're shorter. And they're all numbers, no variables. So let's see here if we can figure this out. Let's work from the inside out. Negative 2 to the second. Now that's a negative times a negative, which is always a positive, so that's 4. And then raised to the third power. 4 to the third, 4 times 4 times 4 is 64. Number 23. Now we have the opposite of 2 squared. Notice the 2 is inside the parentheses. This exponent's inside. So this is, you're not doing negative 2 squared. You're doing 2 squared and then taking the opposite of that. So 2 squared is 4. Then you still have the negative. So that's negative 4 raised to the third. Now that's a negative times a negative times a negative. If I wrote this out, negative 4 times negative 4 times negative 4. A negative times a negative is a plus. So I can make those pluses. But then I multiply by another negative. So I end up getting negative 64. Okay, let's do one more problem here. We'll do number 24. Wow. That is a heck of a math problem right there. Okay. Piece by piece. We go step by step and the problem will work itself out for us. So we have negative 2 to the first, m to the third, n to the negative 1, p raised to the fourth, all of that raised to the fourth power. That means we take all the exponents and we multiply by 4. So it's negative 2, I'm going to put that in parentheses because it's a negative number, negative 2 to the 4 times 1 is 4. M, 4 times 3, that's m to the 12th. N, 4 times negative 1 is negative 4. And then p, 4 times 4 is 16. All right, not bad. Now the second set of parentheses, it's 5 to the 1, m to the 1, n to the second, and p to the 1, all of that raised to the third power. Power to a power, we got to multiply them, so we get times 5 to the third, m to the 3 times 1 is 3, n 3 times 2, n to the sixth, and then p to the third. All right, now that doesn't look much easier, but now you can start combining. But let's just say here, negative 2 raised to the fourth, that's going to give you a positive 16. M to the 12th, n to the negative 4th, p to the 16th. I'll just copy that. Times 5 cubed is 5 times 5 times 5. How much is that? 125. M to the third, n to the 6th, p to the third. Okay, now we're going to multiply. Now it's a multiplication problem. Start with 16 times 125. I would use the calculator on that. You get 2,000. When you multiply variables, keep the base. So keep the m, add the exponents, 12 plus 3. Multiply the n's, keep the base, add the exponents, negative 4 plus 6. And for p, keep the base, add the exponents, 16 plus 3. So we get 2,000. M to the 15th, 12 plus 3, n to the 2, negative 4 plus 6, and then p to the 19th. Now, this is a very, very difficult problem. There's a lot of stuff to do. But if you understand this, then you have a really good grasp on multiplying with exponents and the rule for a power to a power.